Hey there, mathematicians. Today we're going to recognize the relationship between the adjacent digits in a multi-digit number. I have a little quote there for you to read. I just want to validate your hard work this week, and the only way to learn mathematics is to do mathematics, and you've been doing that mathematics. We're going to have a new vocabulary word that we're going to explain, and it's called base 10, and it's about our math system that we use in this country called the base 10 system. And then I'm going to explain to you what that means, because that's going to help you understand the relationship between these adjacent digits. And that word adjacent means the place value next door. So here's the problem from your visual learning bridge that helps you understand this. Going back to that word adjacent, this one here in the hundreds place is adjacent to the 1000s. The 1000s place is adjacent to the hundreds. So look at what they have here. They said Kiana collected 1,100 bottle caps. What's the relationship between the values and the values of the digit 1 in each place? So they're asking us, how are the hundreds and the thousands and these ones related? So I'm going to start with modeling this with mathematics. So we know that we have 1,000. So our cubes here, there's 1,000. If you look at these little cubes here, 1,000 of them make that big 1,000 block. So we have one of these. I'm going to drag it up here so you can see. What is the relationship between that and the hundreds? So we have 100. Knowing your expanded form, if you wrote that out there, that would be 1,000 plus 100. And we have nothing in the ones and tens. So how are those related? Let's look. So here's my 100s. So we have 1,000 and 100. Well, the reason why we call this a base 10 system, something that you've learned back in kindergarten, but you may not have realized that it has to do with how many of each place value makes up the next place value, is that 10 100s make up 1,000. And I'll prove that to you here by pulling them out. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So if you look at all of these here, there should be 10. Let's count them together real quick. I'll put a little dot so you know we counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of these 10 here, they make up 1,000. So another way of saying that in math terms would be 100 10 times, or 100 times 10 equals 1,000. So when we are working through the place value, 10 of any of those adjacent digits will make up one of the next digit. So when you look at here, this 1,000 is 10 times the amount of 100. Let's look at it with 100s. How many tens make up a 100? If you've been paying attention, you should know it should be 10 tens make up 100. But let's just prove it and model with mathematics. Mathematical practice 4. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the blocks are designed to help you see that. Do you see how there would be 10 of these? If I was able to stack these perfectly, there should be 10 in there. So anytime you move across the place value chart, you are multiplying by 10. And that is the case, and it's easy to see that case when your digits that are adjacent are the same digit. So in this example, the digits were both a 1 and a 1 in the 1,000s and the hundreds place. So if I had another look at that, it would be like here, 1,100. The first one we know is a value of 1,000, like this block here. The second is a value of 100. How are they related? 10 of those hundreds are equal to 1,000. So when the digits are next to each other and the number are the same, the value of the digit on the left is always 10 times as great as the value on the right. Let's try it with a 5. So I don't have 10,000s, 100,000s, 1 million, 10 million, 100 million blocks. They do exist, but to keep it simple to understand, let's just go with a 5 in the hundreds and a 5 in the tens. Nice looking 5s, Mr. Hoffman. So knowing this theory, this actual fact here, that we would have to say 5 times 10 would give me the 500s, right? So 5 tens times 10 should be 500. So let's try that. 5 tens would be 50, correct? $50 10 times. So let's do 50 10 times. Going back to my base 10 blocks. How many of these 10s do I need to make 50? Do you know? Should be 5. So 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. It's good to practice counting them out too. 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. There's actually an easier way I could do this. I can copy them. So we should have 10 groups, right? So I'm going to lock these up, group them, and I can copy them. Oh, not like that. So 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6, 7, 8, 9, 10. Here's 50 10 times, right? 1 time, I'll even circle them to make you see them. 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. We said that if we did 50 10 times, it should be 500. Let's look at it. Ready to count? Count with me. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. 10, 20, 30, 40, 50, 60, 70, 80, 90, 300. 10, 20, 30, 40, 50, 60, 70, 80, 90, 400. 10, 20, 30, 40, 50, 60, 70, 80, 90, 500. There are 500 total there, which proves that if we had 10 times the 5 tens, or 50, it should be 500. And if you look at it with the math problem, I'm not sure if you remember this from 3rd grade. I need more room to do that, friends. 50 times 10. You would do 0 times 0. 0 times 5 is 0. Put your placeholder. 1 times 0 is 0. 1 times 5 is 5. Add them up, and you get 500. We'll get to that a little bit later in the year, but just remember, anytime you're going across this place value chart, you are multiplying by 10, and those numbers have to be the same. It's a very important concept when we get to extended facts and we start doing partial products and multiplication. So if you have any questions after the video, mathematicians, feel free to ask. Today, you will be looking at problems like this. I'm going to do number 3 for you. Follow along with your whiteboard if you'd like to. Name the values of the given digits in each number. What is the relationship between the values of the given digits? The 7s in 7,700. So we have 7,700. If you look again, these two digits are the same. So we should know that this one here, the 1000s, is times 10 of the hundreds. Another way of saying that would be, I don't like the way that looks. Let me fix that. Another way of saying that would be that 700s 10 times should be 7,000. So let's pull it out looking at an expanded form. First of all, we know that's 7, and 7,700 is 7,000. And we know that the 7 in 700 is 700. That's the easy part. You know how to do that. You showed me that yesterday. Now you got to remember that relationship between them. And we know that 700 times 7,000 would be 10 times. So this is really going to test your knowledge of the base 10 system and your understanding of this value for each of these place digits. I look forward to working with you, mathematicians. Thank you.